Hey, this is Math 6, Unit 2, Lesson 6, introducing the double number line diagrams. Alright, so we're going to talk about how to use number lines to represent equivalent ratios. And remember, when we talk about equivalent ratios, we're talking about ones that are essentially, and the nice part there is equa, right there, which means just tell us that we're talking about things that are pretty much equal, right? So we're going to look at those today and see how that plays out. Alright, so first of all, we have number talk, and it says adjusting another factor. It says to find the value of each product mentally. So this is something for you to do. What we're going to do here is we just give you in class today a little bit of some quiet think time to kind of process how might you solve this mentally. And so for the first one here, we have 4.5 times 4. So I'll give you a second there. How might you solve that one mentally? And again, if you're watching in class or whatever, you can press pause and then come back. I won't pause for too long, but you probably need a minute for each one to kind of think about it. So this one here, the way I thought about it at least, was I broke this up into a 4 and a 0.5 multiplied by 4. So mentally I went 4 times 4, and I'm writing out what I'm thinking in my head, okay, is 16. And 4 times 5 I know is 20, but because I'm multiplying by a decimal, it becomes just 2. And so 16 plus 2 is 18. So that's how I solved it in my head. I went, that's 16 plus 2 for 18 there. Now when you use this information actually helps you take a look at the second one, because this second one is 4.5 times 8. And so again, using some mental math and knowing what we already know about 4.5 times 4, we can look and see if there's a relationship here. This is the same, and this goes from 4 to 8, which is multiplying by 2. So just using some mental math, I don't have to worry about this part at all. I could. I just said, well, I'm going to think about this being 18 times 2, which is 36. Right? That's one way of thinking about it. If you wanted to think about it differently, you could think about 8 times 4 being 32, and then we're going to add 8, basically half of 8, which is 4 more, so a 32 plus 4 to get you to 36. Both would work. Again, the idea is not which way is the best way, it's just thinking about it, trying to do some products mentally here. On this next one, we see we have 1/10 times 65. Another way of thinking about it is it's 65 divided by 10, like this, 65 divided by 10, or I can think about it as 60 divided by 10 plus 5 divided by 10, right? Because I can take the 65 and break it up. If I was to combine this, because the bases are the same, I get 65 over 10. Well, 60 over 10 is simply 6, and 5 over 10 is a half, so I have 6.5. Works something like that, right? Not too bad. Alright, and for my next one here, I have 2/10. I'm seeing I'm going to double that up there. So if I want to double that up, what would I do? I would take the 6.5, and I'm going to double it up to end up with 13 like that. Okay, from here, we went to activity number 2, which is called drink mix on a double number line. It says the other day we made drink mixtures by mixing 4 teaspoons of powdered drink mix for every cup of water. Here are 2 ways to represent the multiple batches of this recipe. We have the drink mix up above, and we have the water down below. And we can see here that we have 1, 2, 3, 4 teaspoons of the drink mix for every 1 cup of the water. And we did that there, and we did 2 of them there, because what do we do? It looks like here we're making not just 1 batch, but it looks like we're making 2 batches there, right? Okay, so that's our kind of our recipe is 4 teaspoons for 1 cup of water, and it looks like we have a couple there going on, right? So that's what I'm just noticing here with this representation, okay? So this is representing multiple batches, and in this case here, the multiple means we have more than 1, and so we have 2 going on there. So when we take this picture, we can then put it into what we call a double number line form. We have a drink mix here, and we can see that our first batch of drink mix had 4 teaspoons. Our second batch of if we double the recipe, would have 8. And so every time I add another batch, what am I doing? I'm adding another 4 teaspoons of that and 1 teaspoon of water. So if I had a third batch, I'd end up with 12. And so each time I'm going up here, I am adding, in this case here, adding 4, adding 4, adding 4 as I go up on my number line. So 12 to 16 is what I have going on there. So we can actually predict what would go there by recognizing that I'm counting by increments of 4 all the way up. On the water, we see the water is just counting up by 1. 1 cup, 2 cups, 3 cups, 4 cups, and so on. And so what happens then is we can use this double number line to help us figure out how many teaspoons we would need for a batch, how many teaspoons we need to go with each cup of water, things like that. So first of all, number 1 asks us, how can we tell that 4 to 1 and 12 to 3 are equivalent ratios? So it's asking, how can we tell that 4 to 1, this ratio right here, is equivalent to 12 to 3? Meaning, if this was the actual drink mixture, how would we know that they taste the same, right? When we're talking about equivalent, we're talking about things being the same. If we're talking about a drink mix, we're saying they taste the same, like we talked about before with the paint colors looking the same when you mix enough blue with white or whatever it might be. Here we're talking about things tasting the same. So how can we tell that these are going to be equivalent ratios there? So when I look at 4 to 1, I can look at it a couple ways. I can say, well, to go from 4 to 12, to move this way on my double number line, thinking about multiplication, not about addition now, but about multiplication, what would I multiply by 4 to get to 12? In this case here, we would think about 4 times 3 gets me to 12. If I'm doing the same thing with the 1 to get to 3, then I have an equivalent ratio. And indeed, 1 times 3 is indeed 3. Because both parts are multiplied by 3, I end up with an equivalent ratio. I could write it out like this as well. I could say 4 teaspoons to 1 cup of water is going to now be equivalent or equal to 12 teaspoons and 3 cups of water. And again, what I'm looking for is I go across this way, what is the relationship between the numerators and the denominators? It's a times 3 here and a times 3 there, right? I'm basically multiplying this whole thing by 3 over 3, which is equivalent to 1, right? That's all 1. And so I end up with 12 over 3, so it's the same ratio there, okay? And the other thing I can look at is that on the number line, because I have a double number line, these line up vertically. 4 and 1 line up vertically, and 12 and 3 line up vertically. Because they line up vertically, it tells me that they're also going to be equivalent if I've done my double number line properly there. Alright, so now what I want to know is, how are these representations the same, and how are these representations different? Okay, so how are these things the same, the pictures, and how are the number lines the same and different? So looking at, I have a picture representation and I have a double number line representation, right? So how are they the same? In one case, I could say, I'm going to just write here for now, okay? I'm not going to use the back side, so we can look at this together. So in terms of how they're the same, we can see that both representations, the picture one and the double number line, show me representations for 1 batch and 2 batches, right? So they show me 1 and 2 batches. I can tell how many teaspoons and cups I need for 1 batch and 2 batch, and here's 1 batch and 2 batch. That's the same. In terms of being different, I could say that the double number line shows more batches. It shows more ways. Oops, sorry about that. I'm off the page. The double number line shows me more ways I can make the same drink mix, doesn't it? I can make it with 8 and 2, 12 and 3, 16 and 4, and I can keep going. So the double number line allows me to show the different ways to make this batch and not have to draw the pictures again and again and again, right? I could keep drawing more squares every time, but that's going to get kind of cumbersome after a while. A little bit annoying, actually, if you have to keep drawing a picture every time you want to add another batch. This is much easier to do there, isn't it? Okay? Let's see. In terms of how they're the same, we can see that the drink mix, the picture, has the mix on the top and the water on the bottom. Over here we have the mix on top, water on the bottom. Okay? So we could say the order is the same in terms of having mix on top, water on bottom, right? Is that a big deal? No, just kind of something that's the same there. Okay. And let's see, what else is there? In terms of being different, we could say that the first one shows pictures and squares, right, to represent what's happening, and the second one shows numbers and a number line. Those are some major differences there. Now, this third question here asks us, how many teaspoons of drink mix should be used with 3 cups of water? So, to look for 3 cups of water, again, there's a couple of things I can look at. I could either look at this representation, which only really took me to 2, and I could draw another one, which I already did, or I could look at 3 cups of water and recognize that when I have 3 cups of water, the number of teaspoons of drink mix I make is right there vertically right above it. So it's kind of convenient to have the double number line. So we would say in response here that you would need 12 teaspoons, right? That's all there is to it. So, I'm sorry, all I should is showing you the answer there. So 12 teaspoons to go with 3 cups of water because that's what it indicates here on the double number line. For number 4, it says how many cups of water, so looking for the water now, should be used with 16 teaspoons. So now we're going to go the other way. So in this case here, I find 16 teaspoons. So how many cups of water do I need? I take a look there. I need 4, right? So that double number line is really convenient, isn't it? The next question says, what numbers should go in the empty boxes on the double number line diagram? And what do those numbers mean? So taking a look here, what numbers need to go in the spaces right there? Well, one of the easiest things to look at, or easier ways to think about it, is if I have a number or one part of the line that's counting it by ones, that's pretty straightforward to go 0, 1, 2, 3, 4, 5, right? And I could put a 5 right there. Then as another way of thinking about it, for the top number, I know already, we talked about at the beginning, this is adding 4 to each time. Okay, so you might see that this is 16 plus 4, which equals 20. And that would be fine. You could definitely see that. But I could also look at the way we could use multiplication as well. Because here I have the number 1, and in this previous example, we showed that 1 times 3 got me to 3. And if I multiply by the same number up here, the 4 times 3 got me to 12. So using that same method, I could do 1 times 5 to get me to 5, which means I could do 4 times 5, and 4 times 5 is 20. So a couple different ways of doing it. I can recognize the pattern and add the additional amount there, or I could use multiplication to also get to 20. So in terms of the numbers that go in the empty boxes there, we would have 20, and then we would have 5. What do these numbers mean? It means I would need 20 teaspoons for every 5 cups of water, so teaspoons of mix, cups of water, in order to have the same tasting drink mix as the 4-to-1 ratio that the recipe called for. Right? So that 4-to-1 ratio is going to be equivalent to the 20-to-5 ratio. And again, why is that equivalent? Well, because if I multiply the top number by 5, I get 20, and I do the same in the bottom, and I get 5. And because I multiply by 5 over 5, which is 1, that gives me the equivalent ratio 20 over 5. All right, let's take a look at activity 6.3. Here's a diagram showing Elena's recipe for light blue paint. We have white paint and we have blue paint. We have cups and tablespoons. It says complete the double number line diagram to show the amounts of white paint and blue paint in different size batches of light blue paint. So we're going to make a double number line pattern here using the information that I have been provided with right there. Okay, so I'm going to make it on the next page. I see that I have, first of all, I have 1 to 3, or really I have 2 to 6. And I want to look at that there. So I'm going to make a double number line. It's important that I label this here. I'm going to make it, my labels match the picture. So I'll have my white paint here. and I'll have my blue paint here. I could label it with the tablespoons and the cups. That's all fine too. So this is cups, white cups, and this is tablespoon. More details there. And what I know is that on this double number line, what I could do is I could say, well, I have 2 cups of white. Oh, sorry. Sorry about that. I have 1 cup of white. I got ahead of myself. 1 cup of white goes with 3 tablespoons, right? We have 1 cup of white for 3 tablespoons, or I have 2 cup of white for 6 tablespoons. So I can put that in there, and I have 2 for 6, like so. All right, so now you can look at what you have, and it says to compare it with your partner and discuss your thinking there to see if you're in the right idea. I went ahead and kept my ratio lined up to match that picture so that it would just look the same as the picture drawing, right? That's what the picture looked like. Can I continue this double number line? I'm sure that I could, right? Again, it's nice to look at the ones that are counting by ones because you can continue that pattern. 1, 2, 3, 4, 5, 6. And when I look over here, it looks like I'm counting by what? Counting by 3s. Or I can think about multiplying it, right? This is 3 times 2. 3 times 2 is 6. 3 times 3 becomes what? 9. 3 times 4 becomes 12. 3 times 5 becomes 15. And 3 times 6 becomes 18. And so I can actually fill in all those numbers there by thinking about how these numbers are all equivalent ratios. So how many cups of white paint should Elena mix with 12 tablespoons of blue paint? All right, so 12 tablespoons of blue is right here. Here's 12 blue. So how much white would she need? We would say 4 cups. Now the second question is, how many batches would that make? Now in our case here, we have to go back, and it tells us here that the diagram shows us that the recipe for blue paint is 2 of this and 6 of that. Okay, this is, the question would be really, okay, when I look at it, what I would say initially is it should make, we would probably say 4 batches. If a batch is 1 to 3, right, and that's what you have to really decide. I'm not sure what your teacher might say today, because if a batch is 1 to 3, then the answer is going to be it makes 4 batches. But if the batch was like the picture, which was 2 to 6, right? If the batch was 2 to 6 like this, if that's 1 batch, then this would actually just be doubling that, and you'd only get 2 batches. So it depends on what your teacher wants you to look at there, what they see. I'd probably go with 1 to 3 is 1 batch, right? Having 2 and 6 is I'm doubling the recipe. That's what I see it as. So I'd go with 4, but it just depends on how you want to look at there. Okay? How many tablespoons of blue paint should Elena mix with 6 cups of white paint? Well, here's 6 cups of white paint, and how much blue should she mix with it? We would say 18. We would say 18 tablespoons, right? And in terms of how many batches that is, I would count them off 1, 2, 3, 4, 5, 6 batches. Could that be written as something different instead of 6 batches? Yes. You could say it's the 3 batches if a recipe calls for the 2 to 6 ratio. If this is one recipe, 2 and 3, you could say it's 3 batches, but I'm going to leave it like that. Use your double number line diagram to find another amount of white paint and blue paint that would make the same shade of light blue paint. So what else could we use here? We could use, like we said before, we could use 3 white and 9 blue. That would work just fine, right? I could use 5 white and 15 blue, and that would work as well. So looking for other ratios we could use here. How do we know the mixtures would make the same shade of light blue paint? Well, because they're equivalent ratios. That's how we know. When we multiply the top and the bottom numbers by the same number, we create an equivalent ratio. When I take a 1 by 3 and I multiply it by 4 and by 4, that gives me a 4 over 12. So that 1, 3, and 4, 12, which is right here, 1 and 3 and 4 and 12, become equivalent ratios, telling me that they are going to make the same shade of paint. So in summary today, remember that we can use a double number line diagram to find many equivalent ratios. All right, and so you can read through that here. Here's another example of the fizzy cranberry juice there, and that's really the idea behind today's lesson. This double ratio idea you're going to need to know about not only for this unit and this year, but this will come up again next year as well and in the 8th grade. It's a convenient way of looking at ratios and what we call solving proportions. So we'll talk more about that later, but that's it for today's lesson. So we're going to pause there. You can work on your homework, and we'll come back together in just a minute. All right, here we are at homework time. It says a particular shade of orange paint has 2 cups of yellow paint for every 3 cups of red paint. On the double number line, circle the numbers of cups of yellow and red paint needed for 3 batches. Okay, so one batch is 2 to 3. This is one batch right here, 2 yellow and 3 orange. That's one batch. One batch right there is 2 to 3. We want to know how much would it take for 3 batches, right? So think of it this way. I'm going to take this and I'm going to take my 2 and I'm going to multiply it by what? By 3. So 2 times 3 becomes, 2 times 3 is 6. And I multiply this 3 times 3 becomes 9. So how much would I need for 3 batches? Well, it's right here. 6 yellow and 9 red. So essentially, looking from the visual of the double tape diagram, we have 1 batch, 2 batches, and 3 batches right there. So it's really nice to look at that double number line, and you can see where it lines up. There's my 3 batches right there. This double number line, this is number 2 right here. I'm not sure why that 2 is down there, but that's okay. This double number line diagram shows the amount of flour and eggs needed for 1 batch of cookies. So 5 cups of flour for every 3 eggs in my cookies. I think I just want the cookies now, but I don't have cookies right now. That's okay, maybe later. Complete the diagram to show the amount of flour and eggs needed for 2, 3, and 4 batches. All right, so what are we doing here? Okay, to make 2 batches, that means I'm going to have to multiply it by 2. So what is 5 times 2? 5 times 2 is 10. What is 3 times 2? 3 times 2 is 6. To make 3 batches, I'm going to multiply it by 3. So what is 5 times 3? 5 times 3 is 15. What is 3 times 3? 3 times 3 is 9. I could do the 4 by multiplying by a 4, or I could recognize the pattern. I got 0, 5, 10, 15, 20. I could double check what's 5 times 4? 20. Over here we're counting by 3's. 3, 6, 9, 12. I could double check what's 3 times 4? It's 12, so we're in good shape there. What is the ratio of cups of flour to eggs? Flour to eggs. So the ratio is going to be the smallest one we can work with here. So the ratio is going to be right here. We want to make sure we get the order correct. That's important. Flour is 5. The 2 becomes our dot, and the eggs is 3. So it's a 5 to 3 ratio. How much flour and how many eggs are used in 4 batches of cookies? Okay, so in 4 batches, we can look here. Our batches are going to be batch number 1, batch 2, batch 3, and batch 4. So flour is going to be using 20 cups. And the eggs, we would use 12 eggs. All right, I could write it like this, 20 to 12 as well, and that would be a nice way of writing it. How much flour is used with 6 eggs? Well, I find my 6 eggs, and I look up vertically and say, I'm going to use 10 cups of flour. And then finally, how many eggs are used with 15 cups of flour? Well, here's my 15 cups of flour. How many eggs am I using? There it is, 9 eggs. And so the double number line is just really a convenient way of looking at and organizing the numbers you have to work with. Okay? So kind of get used to that. It's a handy way of looking at numbers. Number 3. Here is representation showing the amount of red and blue paint that makes 2 batches of purple. So notice this is 2 batches, right? On the double number line, label the tick marks to represent the amounts of red and blue paint used to make batches of this shade of purple paint. Well, this is 2 batches, so by itself that's 1, and the whole thing combined becomes 2. So keep that in mind there. Well, let's take a look at the next page. Got to turn the pages to write my answer down here. 3 to 2 for red to blue. So I know that one batch is, get on the page here, is 3 red for 2 blue. That's one batch. A second batch is going to double that up, becomes 6 to 4, which matches our picture there, right? Okay, so we're in good shape there. And they want me to keep on, it says label it to, yeah, so let's label it. So what's our pattern? What are we counting up by? Here we're counting by 3s, so we could label it 3, 6, 9, and 12. Down below we're counting up by 2, so 2, 4, 6, and 8. A thing I can put on the top here, I could do my batches, and I know that for my batches, this is batch number 1, batch 2, 3 batches, and 4 batches, right? So just so I have my batches there as well. So how many batches are made with 12 cups of red paint? Here's my red paint, here's my 12. How many batches? It's going to be 4 batches. How many batches are made with 6 cups of blue? Here's the blue, 6. How many batches is that going to be? 3. 3 batches there. All right, so again, the number line helps you see quickly what they're asking for. Diego estimates that there will need to be 3 pizzas for every 7 kids at his party. So 3 pizzas, so 3 pizzas for every 7 kids, right? That's the idea. Select all the statements that express this ratio. The ratio of kids to pizza is 7 to 3. Well, kids was 7, so that's true. Kids is 7, and 2 is that, and pizza was 3, so that matches. That's going to be okay. The ratio of pizza to kids, pizza was 3, kids is 7, so 3 to 7 matches. That's okay. The ratio of kids to pizza, kids is 7, pizzas is 3, 7, 3, 3, 7, not a match. The ratio of pizzas to kids, pizzas is 3, kids is 7, that does not match, not there. And for every 7 kids, there needs to be 3 pizzas. We had 7 kids, and we have 3 pizzas. That is a match. We're good there. All right, so just be careful of the order of the words. Make sure things are lining up the right way there. Number 5, draw a parallelogram that is not a rectangle that has an area of 24 square units. Explain or show how you know. Well, this is when we've done something like this before. So let's take our area. Area is found by multiplying a length times a width. So I need to have 2 numbers that multiply together to give me 24. And perhaps you want to do something like a 12 times 2. I could do an 8 times 3, or I could do a 6 times 4. Whatever you wanted to use. These would all be great numbers to use for your parallelogram. I'm going to go ahead and use 6 times 4, and I'll begin by drawing a base that has a base of 6. 1, 2, 3, 4, 5, 6. So there's my base of 6. I need a height of 4, so I have to go up 1, 2, 3, 4. I need to go up to this line at least, but I don't want to draw a line here. I'll end up with a rectangle. So I'm going to extend out maybe to about here on that same line, and I'll count back 1, 2, 3, 4, 5, 6 to have the same top. And I'm going to connect my dots here and here. My height, though, on a parallelogram will come down to this spot, right? And that has a height of 1, 2, 3, 4. So now I have an area of 6 by 4 is 24. The parallelogram is going to be just what I need it to be. All right. Next one says, draw a triangle that has an area of 24 square units and explain or show how you know. So let's look on the next graph paper. And we want a triangle with 24 square units. So thinking back to what we know about triangles, The area of a triangle is going to be 1/2, right, of the area of a square, which is the base times the height. So half of that square becomes the area of a triangle. So a square is there, we cut it in half, we have our triangle. We want to equal 24. That's our goal. So to get rid of this half, I can multiply both sides by 2. Multiply by 2. So 2 over 1 times a half becomes 1. So base times height is going to equal 24 times 2 is 48. So now with that in mind, I'm just like my parallelogram before. I'm going to draw a triangle that has a base and a height that multiply together to get to 48. So my options are things like 24 times 2, which we just saw there, right? What else could I do? First one I thought of actually was 8 times 6, right? That's a nice one there. It's a nice, it'll fit there nicely, right? I could do 12 times 4 if we wanted to as well. So there are a few other options. I'm going to use 8 times 6 because it just fits nicer. So I'm going to do a base of 8. 1, 2, 3, 4, 5, 6, 7, 8. So there's my base of 8. And it doesn't say it can't be right angle, so I'll count up for a height of 6. 1, 2, 3, 4, 5, 6. My height of 6. And then we connect our dots. And there's our triangle with a base of 8 and a height of 6. So 1/2 of 48 is 24, and it's going to be just perfect. That's it for today. Have a great day, and we'll see you next time.